So today we'll be looking at solving polynomial inequalities. So inequalities are when it's not equal. So that's when it's greater than or less than. So the sign that represents greater than is this. The sign that represents less than is this. So you can remember the greater than sign because it starts with the big side. It's greater than the other side. Okay. You can remember the less than sign because it starts with the little end. It's less than the other side. Okay. Greater than or equal to is the same as the greater than sign, but there is that little extra line to make it include equality. Okay. And then less than or equal to, same as the less than sign, but with the extra line to represent equality. So example 1 here, we want to solve the following inequalities. So here we have our graph of f at x. And if we wanted to state when is f at x less than 0, what that really means is when is f at x negative. And remember, f at x is the y value. So if we look on our graph, and if we highlight all the areas where f at x is negative, then it's going to be those intervals that we want to have here for part A. So the solution for part A would be that x is an element of the real numbers such that it's between -1 and 2. Or between 2 and 4. So that is when our y value will be negative. Okay? And we're not putting equal to because at -1, 2, and 4, it's not negative, it's 0. So now we can do the next one. This time it's asking when is f at x greater than 0. So in other words, when is our function positive? So we're looking at all the regions that are above the y-axis. Sorry, above the x-axis. So the y values are positive. So for B, I'll write it down here so there's more space. It's going to be x is an element of the real such that x has to be less than -1. Or this other segment is when x is greater than 4. Okay, that will give us all the regions where f at x is greater than 0. Now for part C, okay, this time it's saying when is f at x less than or equal to 0? So I'll do this one in blue. So it's 0 at -1. It's less than all the way along here. It's 0 at 2, so we will include that. That's less than all the way to 4, which is 0, so we'll include that as well. So this entire segment actually is less than or equal to 0, so all the way between -1 and 4, including those two endpoints. So to write that out, we're going to say x is an element of the real such that x is between -1 and 4, and we want to include the endpoints this time, so we put the equality there. And then for D, let's erase this so that we can start fresh. For D, it's asking when is it either positive or equal to 0. So we have 3 points where it's equal to 0, and then it's positive all the way along here, and it's positive all the way along there. Okay, so we just need to write out all those sections. So it's when it's less than or equal to -1, or when it's equal to 2, or when x is greater than or equal to 4. So that's how we solve an inequality when it's a graph. Okay? We're just looking at when is it greater than or less than the value that they give us. Okay, in this case, the value is 0. So we're really just asking where it's negative, positive, or equal to 0. Sometimes we aren't given a graph, so we do want to be able to do this algebraically. So to solve a polynomial inequality algebraically, first we will factor the expression, ensuring that one side of the inequality is equal to 0. Note, when both sides of the inequality are multiplied or divided by a negative number, then whatever the inequality is, it actually switches. So if the inequality used to be a less than sign, if you divide by a negative number or multiply by a negative number, it would switch to a greater than sign. Okay? And vice versa is true. If it was greater than, it would switch to a less than. Step 2 is, in your head, pretend that the inequality is an equal sign and find what would have been the roots. And the reason why we're doing this is because if we're talking about something being less than or greater than 0, we're really talking about where is it negative and where is it positive, and when does it change between those two signs. And the only place that a polynomial can go from being negative to positive is if it first passes through a 0. So if it hits an x-intercept, then it has the ability to change signs. So what we do is we find sort of all the boundaries, all those intercepts, all those zeros, and then we do step 3. We use either a number line or a sign chart to test in between all the x-intercepts to find if the graph is negative there or positive there. And then once we know if the function is negative or positive, then we know if it's less than 0 or greater than 0. So that's the steps that we're going to do, and it's going to make a little bit more sense once we do some examples. So here's our first example. They've already given it to us in factored form, and one side is already 0. So what we're going to start by doing is we're going to start by finding what would have been the roots. So in this case, the roots were 1, -3, and 3. Okay. Now you have two choices here. You can use a sign line or you can use a chart. It's up to you. Doesn't matter at all. I will do a sign line for the first example, and then I'll do a chart for the next example. So on the sign line, we're just going to put these x-intercepts in order. So we're going to put the -3 first, and then we're going to put the 1, and then we're going to put the +3. Okay, and then we're going to find a test value. So on this number line, I'm going to find a value that would lie in each of these intervals. So something that's on this side of -3 would be, for instance, x equals -4. Something that's between -3 and 1, x equals 0. Something between 1 and 3, x equals 2. Okay, and you can also use decimals if you wanted to, but if you can use whole numbers, it's easier. And something that's on this side of 3, so greater than 3, would be x equals 4. And what I'm now going to do is with each of these test values, I'm going to plug it in to this expression. And I'm going to do it one bracket at a time. So if I plug the -4 into the first bracket and square it, I would end up with something that's positive. If I plug the -4 into the second bracket, I would get -4 plus 3. I would end up with a negative answer. And if I plug the -4 into the last bracket, -4 minus 3, I would end up with another negative answer. And then if we think about multiplying these three brackets together, I would have done a positive number times a negative number times a negative number. I would get a positive answer. And now you could actually work out what the number is, but we don't care what the number is. All we care about is the sign. Okay, and it's much quicker if you just look at the signs. So let's do it for the next one. If I test 0, if I put 0 into the first one and square it, I get a positive. 0 into the next bracket, I would get another positive. 0 into the third bracket, I would get a negative. Positive times negative. My overall answer would have been a negative. And then doing it for the next one, plugging a 2 in there, we're squaring it, so it actually doesn't matter what it is, it's always going to be positive. Plugging a 2 into the next one, positive. Plugging 2 into the third one there, negative. My overall answer would be negative. Okay, and then for the last one, plugging in a 4, I would get positive, positive, positive. My overall answer is positive. Now, what sections do we choose as part of our answer? Well, we want the area where it is less than or equal to 0. So in other words, we want it to be either negative or 0. So it's negative between negative 1 and 3, and it's negative between 1 and 3. So those are the two intervals where it's negative, and then it's 0 at negative 3, at 1, and at 3. So we actually are going to include this entire region, because that entire region is either negative or 0. So my solution here is going to be x is an element of the reals such that x is between negative 3 and 3, okay. And then we're going to put equality because it can also be equal to those values. Had we not had equality there, then we would have had to split this up into two separate intervals because there would have been a break at the 1. Okay. And if you're using the other notation, then you would write it out as x is an element of negative 3 and 3 with square brackets. Okay, but you can use either notation. I don't mind which one you use. So for our next one, this time it's not factored for us. So the first thing we need to do is move everything over to one side so that it has a 0 on one of the sides. And because we're just subtracting the 24 from the other side, it's not going to change the inequality because that only changes when it's multiplication or division by a negative. Okay. Now we have this. So I want you guys to pause the video and take a few minutes and factor this using the factor theorem. Okay, when you unpause it, you'll get the solution factored. Okay, so after you factored it, you would get x minus 4, x plus 2, and x plus 3. So that means that our roots, okay, if this was set equal to 0, would have been x equals 4, negative 2, and negative 3. So this time I'm going to do the chart method, but once again, choose whatever works best for you. So for the chart method, what I did was I put the roots in order, and I'm going to write down intervals in between each of these roots. So on this side we have the interval of being less than negative 3. The next possible interval is that you could be between negative 3 and 2. The next possible interval is that you could be between negative 2 and 4. And then the last interval is that you could be greater than 4. Okay, so those are all the possibilities. And then along the side here, I'm going to write in all my brackets. So I have x minus 4. I have x plus 2. I have x plus 3. And then I have my entire f at x, so my entire function. Okay, and then just like the sign line, in each of these intervals, we're going to choose a test value and we're going to plug it into each of these brackets. So when x is less than negative 3, a number like negative 4, if you plug negative 4 into this bracket, you get a negative. If you plug negative 4 into that bracket, you get a negative. Negative 4 into this bracket, you get a negative. Negative, 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 all multiplied together would give you a negative. And you're going to do this for each and every one of them. So next you could try plugging in a negative 2.5. And if you did that for all 4 of them, this is what you would get for the signs. Now we wanted it to be greater than or equal to 0, so we want the positive regions. So I took the 2 positive regions, and then what's nice here is that you can actually just read off your answer because it's going to be those intervals, and because we want equality, we're just going to put equal signs on them. There would be our answer with the 2 intervals selected, and then if you want to write it in the other notation, this would be your answer down below. So you guys can now get started on the homework.